Greetings. In this video, I would like to kind of expand on this concept of effect size and talk about the first way to kind of conceptualize this, which is what we call the raw or unstandardized mean difference. So let me go ahead and get this up on our work surface here. Raw or unstandardized mean difference. Okay, when can you use before we even talk about what it is, let's just talk about when you can use it. The raw or unstandardized mean difference can be um, used when the outcome is reported on a meaningful scale. On a meaningful scale. What does that mean? Okay, well, an example. What's a meaningful scale that is kind of all parties are kind of familiar with a scale, something like maybe blood pressure. So everybody's familiar with the blood pressure scale, millimeters of mercury, kind of systolic over diastolic. Maybe everybody's kind of familiar with IQ or GRE scores or something like this. It's reported on a meaningful scale, and I'll put semicolon here. All parties have familiarity. All parties familiar. Okay, this will become more intuitive as we go along. So the basic calculation we'll start with for an independent t-test or independent groups. So when we're talking about a standardized mean difference, D, capital D here just means difference. And this is going to be really easy, folks. It's just the mean of group 1 minus the mean of group 2. And our nomenclature here is that the uppercase D we use for the raw mean differences. And if we switch to a lowercase, which we will in subsequent videos, we do a lowercase d, we use that for the standardized version, standardized mean difference. Okay, just want to clear up our nomenclature right off the bat here. Okay, so let's just kind of get into an illustration here. Suppose you had a study with mean IQ scores of group 1 with a 103, the mean of group 2 with 100. And suppose that there was some intervention where, group 1 got some kind of reading program or memory program or test taking program or something that was an intervention that was going to help them increase their IQ, and group 2 didn't get it. And so what we're basically saying here is with this raw unstandardized mean difference, it's kind of just the top half of the t. Something happened here. Just the top half of the t equation, right? So remember our t-test equation was just the mean bar of, or x bar of group A minus the x bar of group B divided by this standard error of the differences between group A and group B. So what are we doing here? We're just essentially doing the top half of this in the unstandardized mean difference. So D then equals 103 minus 100, which equals 3. So what was the effect of your treatment? Your treatment, in this case, your intervention, your memory training protocol or whatever it was, increased IQ on a standardized test, IQ test by 3 points, 3 IQ points. So treatment raised IQ by 3 points. Okay, so that's a independent t-test calculation for the raw or unstandardized mean difference. Now let's just say you had, I guess, let me kind of wall this off here. It's kind of ugly, but oh well. So calculation for dependent groups or matched pairs. T-test. Calculation here, again we're using big D, equals the mean of different scores. So suppose, similar study, where you get the following raw data. Let's just say you had pre-test scores and you had post-test scores. Then the D column is the difference score. Let's just say pre 10 here was 5, 16, and 10, 12, and 8. Just 3. We're just going to do 3. So pre-test minus post-test. Here is going to be a difference score of 5. Here's a difference score of 6. Here's a difference score of 4. So what is the mean of the different scores? So this would be x bar diff equals 5 plus 6 plus 4 equals 15. To get a mean, you divide by the total n, equals divided by 3. 15 divided by 3 is 5. Okay? So if D equals the mean of the different scores, then it is 5. Okay? So in this case, what are we saying? Whatever your treatment was here that happened between, let me just put that in blue just to make this, I guess, concrete for us. If this was your treatment happening between these 2 points, the treatment was consistently causing your group to lower as a function of time. Lower by how much? It was statistically different from 0, right? Because the null here is going to be that the mean of the different scores equals 0, right? There was no difference between pre and post. You were different from 0. It was a 5. You're saying that's statistically different from 0. What is its magnitude? The magnitude here is 5. So this is just, it seems silly that we would even talk about this, but when you're not using common scales, or when you need to compare the effect of a treatment that might have different outcome variables. In other words, I might have given you this, 2 different studies might have used the same cancer treatment drug, but different outcome variables, and you want to be able to compare the effect, the magnitude effect of that drug on whatever the outcome variables were. Maybe the one drug looked at survival rate, and the other one looked at activities of daily living, and you wanted to see if there were similar treatment effects on those 2 outcome variables using the same cancer treatment drug. So in that case, you can't use the raw unstandardized mean difference score anymore. You have to make it unitless. And one of the things that I haven't shown you yet here is that when you're doing these here, this has units attached to it. This has units attached to it. with their IQ units, blood pressure units, or whatever. And so this difference score has units in it. Same thing here. The pretest might have units in it. The post-test has units in it. And so this capital D, right, the mean of our difference scores, has units in it. So the units are intact in all these. So they can't be compared if you're using a different outcome variable that has different units. And so that's kind of where the standardized mean difference comes in, is now it's going to act similar to kind of like a z-score, where we get a unitless value and we can kind of look at an effect or a magnitude of your treatment and compare it across different studies. So that's all for raw unstandardized mean difference. I hope you enjoyed the video.